Okay, get this. What if I told you that the simple stuff inside your pencil, graphite, is also a key ingredient in high explosives? Yeah, today we're diving into the secret, surprisingly powerful, and sometimes literally explosive life of graphite.
I mean, we all know it, right? It's the stuff that lets us sketch, write, maybe erase a few mistakes. It's simple, it's common, and let's be honest, it's kind of boring. It's just graphite.
But what if that same simple material is also at the heart of some of the world's most powerful materials? We're talking a key ingredient in high explosives, a tool for detecting bombs, a shield against corrosion, and even a player in phenomena that totally redefine the word explosive itself. All right, so let's start with the most direct connection. It turns out graphite isn't just near explosives, it's often put inside them, on purpose, which seems completely counterintuitive, right? So why on earth would you add pencil lead to a bomb? It feels like adding sand to a jet engine. But there is a fascinating scientific reason for it. Well, it's all about control. See, scientists add graphite and its supermaterial cousin, graphene, to make explosives more powerful and more stable. Those tiny graphite particles, they act like microscopic little hotspots inside the explosive. This helps the whole chemical reaction kick off more evenly and spread way faster. It's all about fine-tuning the power and the safety of some really potent stuff. Take this, for example. In one study, researchers took an already powerful military-grade explosive and they carefully mixed it with graphite and wax. By getting all these ingredients to crystallize together just right, they measured a pretty significant bump in performance. How much? Well, check this out. A 3.6% increase in detonation velocity. Now, I know what you're thinking. 3.6%? That doesn't sound like a lot. But listen, in the world of high-performance explosives, where every single meter per second counts, that is a huge impact. It's a massive leap in performance, a serious boost in power, all from a seemingly simple additive. And it's not just graphite. Graphene, its single-atom thick cousin, plays a really similar role. So when you add it to pyrotechnic compositions, it actually increases their sensitivity. Graphene is just so good at absorbing energy that a study showed adding just a tiny bit makes them way easier to set off with an infrared laser. Basically, it makes them more reliable and quicker on the draw. Okay, so if graphite is intentionally put in explosives to make them better, well, that leads to a pretty serious and kind of dusty question about its raw form. I mean, if it's in explosives, could graphite dust be explosive on its own? We all know that lots of different kinds of dust can be explosive. Flour, sawdust, even sugar. So what about graphite dust, especially in a factory or something? Well, the answer, it turns out, is complicated. And this is where the science gets really interesting. It's like a tale of two tests. A researcher, N.L. Poletav, ran two very different experiments. In the first one, using a small 18.7-liter chamber, he cranked up the heat and pressure, and bam, the graphite dust was explosive. But then, he ran a second test in a much larger chamber, 1 cubic meter, under just normal, everyday atmospheric conditions. And the result? Nothing. It was completely non-explosive. And Poletayev's own conclusion says it all, really. He wrote, under normal atmospheric conditions, GDAM, which is just a graphite dust air mixture, is explosion-proof. So context is everything. It was the conditions of that first test, the high heat and pressure, that caused the explosion, not the dust itself. This means that for most real-world situations, graphite dust is actually quite safe. So we've seen graphite as an enhancer and a potential conditional hazard, but now let's just flip the script completely. Let's look at how this same family of materials can actually be a protector. That's right, it goes from hazard to hero. The very same stuff that can boost an explosive can also be used to detect them. It's pretty incredible. A team led by Maria Souza developed a really clever device for this exact purpose. Get this, they made a 3D printed TNT sensor. It's made from recycled plastic, which is awesome, and then infused with graphite and carbon black. This creates this rough little electrode surface. And here's the brilliant part. You just rub the sensor on a surface you're checking out, and it picks up any tiny explosive residues. Then you can detect it. It's cheap, it's portable, and it's just plain smart science. But protection isn't just about detection. There's another amazing application called graphite blasting.
So here's how it works. You take a special nozzle and aim graphite powder at a surface. Then you use high-pressure air to just blast that powder onto the material. But here's the cool part. Instead of destroying the surface, it actually forms a durable protective layer of graphene right on top. It's like reverse sandblasting. And the results of this process, they're pretty stunning. When they did this to aluminum, the new graphene layer doubled its corrosion resistance. It also boosted its thermal stability by about 5%. You're literally creating a physical shield on a material by blasting it with the stuff from inside a pencil. It's wild.
All right, for this last section, we're going to get a little bit conceptual. See, we've been talking about the word explosive in a very literal sense, right? A bang, a boom. But in the world of science, that word has a much, much broader, and you could argue a more interesting meaning.
You see, the word explosive in science doesn't always mean a literal bang. It can describe any rapid, really dramatic change. Think of it like a system that just suddenly snaps from one state to another. And guess what material is often at the heart of these kinds of scientific explosions? You guessed it, graphite and graphene. So first up, we've got something called explosive boiling. So picture this. You have a superheated graphene surface, and you put a little bit of liquid on it. Well, according to research, the heat transfer is so incredibly efficient that the liquid doesn't just boil, it vaporizes, like instantaneously in this violent explosive burst. Okay, then there's explosive emission. This happens in some really high-power microwave sources. You use a graphite cathode, that's basically the negative terminal, and when you hit it with a super strong electric field, it doesn't just leak a few electrons, no way. It unleashes this sudden, intense burst of them all at once, an explosive emission. And finally, this one is my personal favorite, explosive percolation. Okay, imagine you're adding tiny graphene flakes into a non-conductive material, like a plastic. As you add more and more, the conductivity kind of slowly creeps up. But then you hit this magical tipping point where just one more flake connects everything together, and the material's electrical conductivity suddenly, explosively jumps by an insane amount. It's this incredible, abrupt switch from an insulator to a conductor. So there you have it. From the point of a pencil to the very edge of physics. We've gone from a simple writing tool to high explosives, to bomb detectors, to protective shields, and even to redefining the meaning of the word explosive itself. It just makes you wonder, doesn't it? What other everyday materials are out there, hiding these extraordinary secrets in plain sight?